There are 2 trillion galaxies in the observable universe. 2 trillion. Each one contains hundreds of billions of stars. If you tried to count every star at 1 per second, it would take longer than the current age of the universe. 3 times over. No human being and no team of scientists could ever map this. Not in a lifetime, not in 1,000 lifetimes, but an AI can. And it has already started. Here is the problem that kept astronomers awake for decades. Telescopes have always been getting better. Bigger mirrors, sharper sensors, greater range. By the early 2000s, we could see further into space than any generation before us. We could photograph galaxies 12 billion light years away. But seeing something and understanding it are very different things. Every night, modern observatories generate terabytes of raw data, thousands of images, millions of objects, stars, galaxies, gas clouds, quasars, all mixed together in a flood of information that no human team could process fast enough. By the time scientists finished analyzing one night's worth of data, 3 more nights had already passed. The universe was outrunning us. And here is what made it worse. The most important things in the universe are nearly impossible to see directly. Dark matter, dark energy, the invisible scaffolding that holds every galaxy cluster together. Scientists have known for decades that it exists. It bends light. It shapes the structure of everything. But you cannot photograph it. You cannot point a telescope at it and take a picture. The only way to find it is to map what you can see and read the shadow it leaves behind. That requires processing millions of objects simultaneously, tracking tiny distortions in galaxy shapes, running statistical models across datasets so large they crash conventional computers. This was the wall humanity hit. We had the telescopes, we had the data. What we needed was a mind that could hold the entire sky at once. Enter the machines. The first major breakthrough came not from a discovery in space, but from a competition on the ground. In 2010, astronomers started testing whether machine learning algorithms could classify galaxies automatically. The results were shocking. In the time it took a human expert to classify 500 galaxies, a trained algorithm classified 5 million with the same accuracy. That was not an improvement. That was a different category entirely. Within a decade, AI was not just classifying galaxies. It was finding things humans had missed entirely. Here is one example that stopped the scientific community cold. The Sloan Digital Sky Survey had been cataloging the night sky since the year 2000. Millions of objects, thousands of papers published. Scientists assumed they knew what was in the data. Then a deep learning model ran through the same archive and found over 30,000 previously uncatalogued objects. Faint galaxies, rare quasars, gravitational lensing events that human reviewers had looked at and passed over. The data had been sitting there for 20 years, hidden in plain sight. But this was only the beginning. In 2023, the Dark Energy Spectroscopic Instrument, called DESI, went fully operational. DESI is a telescope in Arizona fitted with 5,000 individual optical fibers. Each one can target a different galaxy simultaneously. Every night, it records the light spectrum of up to 100,000 objects. The goal: map the 3-dimensional positions of 40 million galaxies across 11 billion years of cosmic history. No human team runs this. The data pipeline is almost entirely automated. AI systems classify every object, AI models calculate distances. AI algorithms detect patterns in how galaxies cluster together, patterns that reveal the imprint of dark energy on the structure of the universe. In its first year of full operation, DESI produced the largest three-dimensional map of the cosmos ever created. And then DESI found something unexpected. The map showed that the clustering of galaxies did not quite match what our standard model of cosmology predicted. The discrepancy was small, but it was consistent, and it appeared across multiple independent data sets. This is connected to what scientists call the Hubble Tension. Measurements of how fast the universe is expanding do not agree with each other, depending on how you measure them. DESI's AI processed data gave the clearest picture, yet that something in our understanding is wrong. The universe is expanding faster than our best models say it should be. That means our equations, our textbooks, our entire framework for the history of the cosmos may be missing something fundamental. But it gets deeper. The Vera C. Rubin Observatory in Chile will reach full operations in 2025. Its camera is the size of a small car. It will photograph the entire southern sky every 3 nights. In 10 years, it will produce 30 trillion individual observations. 30 trillion. That number is so large, it barely holds meaning. The human brain did not evolve to process 30 trillion of anything. The AI systems being built for Rubin's data pipeline will do something no scientific instrument has done before. They will detect change, not just what exists in the sky right now, but what has shifted since the last photograph. Every 3 nights, supernovae appearing in hours, asteroid orbits that shift, gravitational microlensing events, moments when a dark object passes in front of a star and bends its light, lasting less than a week. Events that were always happening, but that no human surveyor was fast enough to catch. The machine will catch all of them. If you find this as fascinating as we do, hit subscribe. We go this deep on AI and science every single week. And then there is the cosmic web. The universe is not a random scattering of galaxies. At the largest scales, it has structure. Galaxies cluster into filaments. Filaments connect into nodes. Nodes are surrounded by enormous empty voids, hundreds of millions of light years across. Together, it looks like a 3-dimensional web, eerily similar to the neural network of a human brain. This structure could not be properly mapped until AI arrived. The filaments are too faint to photograph directly. You can only detect them by finding the gravitational influence they exert on the galaxies around them, by analyzing the statistical distortion in the shapes of millions of galaxies at once. A 2024 study used a deep learning model trained on simulated universes to detect dark matter filaments in real observational data for the first time. It found them across scales of hundreds of millions of light years, the invisible backbone of the universe, made visible by a machine that had never existed before. So what does this mean? Let us step back and think about what has actually happened here. For most of human history, our picture of the universe was built by individual human minds, observing and calculating. Galileo with his telescope, Edwin Hubble at the eyepiece, Vera Rubin counting galaxy rotation curves by hand in the 1970s. The very woman the new observatory is named after, doing that work manually, night after night, year after year. Those individuals changed everything, but each of them was limited by human speed, human attention, human lifespan. The AI systems now mapping the universe are limited by none of these things. They do not sleep. They do not miss patterns from fatigue. They can hold in working memory the shape of 40 million galaxies simultaneously and detect a statistical anomaly across 50,000 of them. What this means, practically, is that we are entering a phase of astronomical discovery, unlike anything in history. Not slower discoveries, not the same number of discoveries, more discoveries per year than in all previous centuries of astronomy combined. We are already seeing the beginning of this. In the last 5 years, AI models have detected thousands of new gravitational lens candidates, places where a massive object is bending the light of something behind it, which lets us calculate the hidden mass in between. They have found hundreds of previously unknown dwarf galaxies orbiting larger ones, tiny satellites that our models of galaxy formation say should exist, but that human surveys kept missing. They have mapped the three-dimensional distribution of hydrogen gas across vast regions of space, revealing the flow of matter along dark matter filaments. And most recently, AI has begun detecting anomalies, unexplained structures, patterns in the data that do not match our simulations. Scientists call these tensions cosmological tension, Hubble tension, S8 tension. Each one is a place where the data disagrees with the model, where the universe is telling us something. We do not yet fully know what. That is the honest answer. The AI is generating discoveries faster than human theorists can interpret them. We are in a moment where the observations are ahead of the theory, where the map is showing us territory that our physics has not yet described. For some scientists, that is deeply unsettling. It means the lambda CDM model, the framework that explains the Big Bang, dark matter, dark energy, and the expansion of the universe, may be fundamentally incomplete. For others, it is the most exciting moment in the history of science, because every time our model has disagreed with observation, that disagreement has eventually led somewhere extraordinary. General relativity came from a tension between Newtonian gravity and the orbit of Mercury. Quantum mechanics came from a tension between classical physics and the behavior of light. Every revolution in physics has started with a mismatch. The AI mapping the universe is finding mismatches everywhere. There is one final thing worth saying. The AI doing this work does not know what it is finding. It does not understand dark matter. It does not feel awe at the cosmic web. It processes numbers. It optimizes functions. It finds patterns. The meaning of what it finds is entirely human, which means the greatest discovery in this story is not that machines are mapping the universe faster than we can. It is that by building these machines, we have extended the reach of human curiosity into territory our biology alone could never touch. We are 2 trillion galaxies into a map that has no edge, and we have only just started. If you found this worth watching, hit subscribe. We post every week. From AI to the cosmos, there is always more to find.